there and kind of show you a little bit of where we are. So this is the scenery here, beautiful, and this mine, and actually you can see the modern solar panels that have been installed, and that plastic pipe conduit actually leads into the mine. And you can see that there is a steel door to block the mine. All right, now you can see that it's, you know, well bedded, and this lends itself to a demonstration of the Brunton compass. So that's what we'll do next. And you know, this little thing was very spontaneous, so it's just ad lib, not rehearsed. But I am noticing, you know, as I approach the mine, you might have seen bedding. That is not this surface. This surface is actually a joint surface, because and that might be of interest. That is, maybe we're here to measure joints, so that's a perfectly legitimate reason to take this measurement. But I wanted to point out, this is not the bedding that you saw a moment ago, and that is just kind of, the snow makes it kind of difficult to get to a good spot to take that measurement. And because this is just a demonstration of the Brunton compass, what does it matter? Okay, I'm going to take my measurement consistent with the North American right arm rule. That surface dips away from you right now, right? Away from the camera. And I'm noting the sun is over here, that's north, so it basically dips to the east, which means when I take this measurement in terms of the strike, I'm going to want to take that measurement, you know, the azimuth pointing toward the north, so that my right arm is going to preserve the direction of the dip. So let's do that. Let's bring, and Logan, could you come over close to the top of this compass? And so, I'll tell you what, I'm going to turn it around so you can see that level. And that demonstrates that it really doesn't matter, right? Remember, it doesn't really matter. I just got to know what I'm doing. So what I'm being careful here, I'm making sure that edge right there is firmly against the rock, and then the bullseye level right here has to be leveled. That being the case, this is a perfectly good measurement. You can see the white tip of the arrow, and that says 160, or maybe 159. You see it? Now, however, I don't want to record it that way. I want to record it as 339, or maybe 340, this end, because that is expressing the direction toward the north. Does that make sense? So the strike here on this joint now, not bedding, but joint, is 339. And that is an azimuth. Very good. So now we want to measure the dip. And we have not rehearsed this, and we should have. Because this is going to be difficult. Okay, but you know, you've seen this before. Maybe we can do this. Can you get into a position where you can see the front of that compass now? All right, so now I'm using what I call the spirit level. You see it? And I'm going to level it up. And I think that just occurred by that level. That's that level right there. And now the dip is recorded right here. Okay, now you can probably see it, but I'm going to bring it away since that's static and put it in a position where I can actually see it better. And that dip is 50 degrees. All right, if you can see that. It has a vernier scale on it also, but that center line between the two 60s, that's the 0 point, and that is simply saying 50 degrees. So Logan, if you come back to this surface, so that surface, the full measurement, in my notebook, we'll simply say this is the joint 339 and 3 digits used for an azimuth, 339, and the dip is 50 degrees. All right, that pretty much does it.